All right, so now we'll take a look at the third video in the series of solving trigonometric equations. So we've gone through and done some of the basic ones where you create a recursive formula and then figure out what are the values that will make it work. And then we went through and took a look at examples where we had a change in the period, so therefore it was either compressed or stretched along the x-axis. We've also done quadratic type, and we're going to continue that theme of quadratic type here. But before we do that, we have an issue here where we've got sine squared x minus cosine squared x minus cosine x is equal to 0. So the problem here is that we've got two different trig functions, and for me to go through and use quadratic type equations, I have to have the same trig function. So that means I'm going to have to do some work here. I'm going to have to change my sine squared x to something different, so that way I can go ahead and simplify. So I'm going to have to use my Pythagorean identity. So sine squared x plus cosine squared x is equal to 1. I need to change this sine squared x. I'm going to substitute. So I need sine squared x by itself. So sine squared x is equal to 1 minus cosine squared x. So I'm going to use this and substitute it in here. So now I end up with, excuse me, I end up with 1 minus cosine squared x minus cosine squared x again minus cosine x is equal to 0. So now I've got to rewrite this. So I'm going to combine my like terms. I've got negative 2 cosine squared x and then minus cosine x plus 1 equals 0. I'm going to change these. I'm going to go ahead and turn this into, divide both sides by negative 1, because we like to have that leading coefficient to be 1. It's not going to change any of the values. So 2 cosine squared x plus cosine x minus 1 is equal to 0. So I've got to factor this. And what I'm going to want to do is, this is overly complicated for me to use some of my forms that I've used before for factoring. So I'm going to make my life a little bit easier. And I'm going to say let y equal cosine x. So that means I can rewrite this as a quadratic. So 2y squared plus y minus 1 is equal to 0. This is easier to deal with than to look at this. So I can go ahead and factor this because I'm more comfortable with it. And I'm going to use the division method for factoring, where I put 2y here, 2y here. So 2y times 2y is 4y squared, so I need to divide by 2. Then this becomes negative 2. So that means the signs are going to be opposite of one another, plus, minus. I need factors of 2 that differ by 1. So it's 2 here and a 1 here, which then gives me, divide the 2 into these two parts, and I get y plus 1 times 2y minus 1 is equal to 0. So now, knowing that I let y equal cosine x, I'm going to come back over here. So now this means I have cosine x plus 1 times 2 cosine x minus 1 is equal to 0. So that means cosine x is equal to negative 1, and cosine x is equal to 1/2. So I've got to remember when these happen. Okay, so cosine is negative 1 if the angle is located. So think about it. It starts at the top, crosses at pi over 2, comes down to the bottom at pi. And then cosine is 1/2. So cosine is 1/2 when I am in quadrant 1 and when I'm in quadrant 4. And that happens when we are at pi divided by 3. So then pi divided by 3 in the fourth quadrant would be 5 pi divided by 3. And again, since I don't have anything in front of the x's here, I don't have to worry about creating a recursive formula, because remember, the whole idea is I'm going to add 2 pi to it. If I add 2 pi to pi, I'm going to be outside the window. If I add 2 pi to any of these, I'm outside the window. So therefore, I just have to put them in order now. X is equal to pi divided by 3, pi, and 5 pi divided by 3. All right, so there's our first example. Again, the idea was, first off, I had to do some modification first because of the fact that I had a sine squared, but I really needed only cosine squared. So it was the Pythagorean identity to the rescue, go through, change out what sine squared x is to the 1 minus cosine squared x through substitution, simplify, and then instead of trying to deal with all the cosines, I just went through, and I've suggested this to a lot of my students, to go through and just change it so that it's something you're more comfortable with. You know, a y, an x, whatever. Doesn't matter what the letter is, just so long as it's something we're more comfortable with. All right, next example. So this one, I'm just going to rewrite. So I've got 8 sine squared x plus 6 sine x plus 1 is equal to 0. I've got to factor this. So in order for me to factor, I'm going to try and go through and do, again, the division method. So I need 8, and I'm going to say let y equal sine x, just so that it's a little bit cleaner. All right. So then 8y, and I have an 8 in the denominator. So I need to multiply this by 8. This tells me the signs are the same. They're both positive. Factors of 8 that add to give me 6, well, that's 2 and 4. 8 does not divide evenly into either of these, so I have to break the 8 apart. 2 times 4. 2 will divide into this one. 4 will divide into this one. And I'm left with 4y plus 1 times 2y plus 4 is equal to 0. I'm sorry, not 2y plus 4, 2y plus 1. So now I come back over to here, and that means then I've got 4 sine x plus 1 times 2 sine x plus 1 is equal to 0. So then that means I'm looking for when is sine x equal to negative 1/4, and when is sine x equal to negative 1/2. Sine x being negative 1/2. Okay, if it was just 1/2, it would be pi over 6. But I need the proper quadrants. So that would mean it's in quadrant 3 and in quadrant 4. So again, the reference is pi over 6. So if I'm in quadrant 3, the reference, right, going all the way around, is going to be 7 pi over 6. And then if I'm in quadrant 4, I'm at 11 pi over 6. And the reason I don't use the negative pi over 6 is because, again, this interval tells me that I have to be between 0 and 2 pi. So now the problem is, I don't know this off the top of my head. I have no idea what that value is. This is not one that we know. So therefore, I've got to go through and use the calculator. And it's going to give me one of them, but I have to make sure I have both quadrants, because remember, we're going to do the inverse sine. So I'm going to use my handy-dandy calculator, and I'm going to do the inverse sine of negative 1 divided by 4. And that gives me, I got to make sure I'm in the right mode, right? So you got to make sure you're in the right mode. I am in the right mode. I'm in radians. Okay. So now I'll go ahead and get out of here. So second quit. This is not one that I know, so therefore I have to use the calculator to get me my values. So this means then the calculator says x is equal to negative 0.25268. So I'm just going to say negative 0.253. Now the problem with that, this would be in quadrant 4. So my angle here is 0.253. What I need to do is, remember, it's in this quadrant and in this quadrant. So these are my two reference angles. So now I've got to figure out, okay, well, where is that going to be? I've got to add 2 pi to this. And then to come all the way around to here, I'm going to add 180 to this, 180 degrees, which I'm sorry, is pi. So I have to take that positive 2.53, add pi, and this negative 2.53, I'm going to add 2 pi to. So that means x is equal to, so I'm going to take that negative, and I'm going to, hold on one second, I'm going to store that value so I can remember. Store, oh, sorry, clear. Store to, we'll call it x. All right. So now I'm going to take that value and I'm going to add 2 times pi. And that gives me 6.031. That's this one right here, because I had to add 2 pi to get all the way around. And then I'm going to add to the original pi, and I get the second value, which is 2.89. So these are 2 values that I have no choice but to go through and write them in this manner. So now when I go to write it, again, this is in this quadrant and this quadrant. Over here, these are also both in that quadrant. Okay, so now that means then, okay, x is equal to, so this one would be first. If you don't believe me, take what 7 pi is, divide by 6, so that I know which one has to go first. So this would be 2.89. And then 7 pi divided by 6 is 3.67. I'm going to say, whenever possible, leave them in the values that are exact. Because again, these are approximations. Okay. And then 6.031. Okay. And actually, this should be, 8, 9. Let me erase that. It makes it easier. If I'm doing 3 decimal places for one, I should do 3 decimal places for the other one. So this then becomes 2.889. All right. So this is an example of where, hey, I might know some of the values, but then there are other examples where I don't know the values. And this is what the solutions would be in radians. All right. So, and then of course I write them in order. And there you go. So again, here's the third and final installation of our solving trigonometric equations. My name is Robert Main, and I hope you have a great rest of your day.